This question is from 2002 summer, paper 1 of the further maths exam, and it's question 5. The roots of the equation x cubed minus 3x squared plus 1 equals 0 are denoted by alpha, beta, and gamma. And then it says show the equation whose roots are alpha divided by alpha minus 2, beta divided by beta minus 2, and gamma divided by gamma minus 2 is 3y cubed minus 9y squared minus 3y plus 1 equals 0. So we can do this using a substitution, and we can observe the function that sends, well, alpha to alpha divided by alpha minus 2, beta to beta divided by beta minus 2, and gamma to gamma divided by gamma minus 2. So f of z equals z divided by z minus 2. This function is actually invertible, and we can find the inverse very quickly. Y equals z divided by z minus 2. If you rearrange that equation, you get zy minus 2y equals z. Bring all the z's to one side, so zy minus z equals 2y. And then, well, factor out the z, so z times y minus 1 equals 2y. And so z equals 2y divided by y minus 1. So if that's our function which takes the roots to these values here, we know that f inverse of z is equal to 2z divided by z minus 1. And if this is our polynomial, p of z equals z cubed minus 3z squared plus 1, and if that's equal to 0, then we know that p of f inverse of z is also equal to 0 for z equals alpha, beta, and gamma. So that means if we substitute this thing into our polynomial, then we are good. So let's go ahead and do that. So we got 2z divided by z minus 1 cubed minus 3 times 2z divided by z minus 1 squared plus 1 equals 0. So 8z cubed divided by z minus 1 cubed minus 3 times 4z squared, so 12z squared divided by z minus 1 squared plus 1 is equal to 0. And then from there we can multiply through by z minus 1 cubed. So we get 8z cubed minus 12z squared times z minus 1 plus z minus 1 cubed equals 0. And then from there, so we got 8z cubed minus 12z cubed plus 12z squared, and then just expand that out, z cubed minus 3z squared, and then plus 3z, and then minus 1. And then we just simplify. So 8 plus 1 is 9, minus 12 is negative 3z cubed, and then plus 9z squared, and then plus 3z, and then minus 1 equals 0. And is that what we were supposed to have? Almost, it's just it's on the other side, and they call it y instead of z. So bring everything to the other side, we get 3y cubed minus 9y squared minus 3y plus 1 equals 0, which is exactly what we were supposed to have. And this thing has roots alpha divided by alpha minus 2, beta divided by beta minus 2, and gamma divided by gamma minus 2. Alright, now up next we are asked to find this thing here, and we can clearly see that if we take the product of all three of these roots, then this is going to be the denominator of that fraction. So we have, let's go ahead and take that product, alpha, beta, gamma divided by alpha minus 2 times beta minus 2 times gamma minus 2. Right, and since it's the product of the three roots of this polynomial, that means it needs to equal negative d. Remember, this is a, b, c, d. So negative d divided by a. So it's going to be negative 1 divided by 3. And we actually, if we go back up and look at the original polynomial that had our roots alpha, beta, gamma, we see that alpha, beta, gamma this time needs to equal negative 1 divided by 1. So negative 1. And so, since alpha, beta, gamma equals negative 1, we have that alpha minus 2 times beta minus 2 times gamma minus 2 is equal to 3. Now the last part of this question asks us to find this sum here, and well, I mean, you stare at it for a little while, and then you realize that if you add the roots together, then on the denominator you're still going to have this product alpha minus 2, beta minus 2, gamma minus 2, but on the top you're going to have this thing here. So adding these roots together is equal to this thing divided by alpha minus 2 times beta minus 2 times gamma minus 2. So this is equal to the sum of the roots. Alright, and the sum of the roots is clearly going to be equal to negative 9 divided by 3, since it's negative b divided by a. So that is positive 9 divided by 3. So that is, well, I'll just leave it as positive 9 divided by 3, because as we worked out before, the thing on the bottom is actually equal to 3. And so that means the thing on the top is actually equal to 9. So let me just circle that. Yeah. So the answer is 9. And then I think that was, yeah, that's it for this question.